Integration by parts 8. In this video, we're going to prove the reduction formula. Integral sine to the nx dx is equal to negative 1 over n cosine x times sine to the n minus 1x plus n minus 1 over n integral sine to the n minus 2x dx. This is valid for n larger or equal to 2. Our strategy will be to apply integration by parts and trig identity. So integral u dv is equal to uv minus integral v du. We're going to start by writing this integrand as integral sine to the, we're going to factorize a sine x from this. So sine to the n minus 1x times sine x dx. Why do we write it in this way? The reason is because we're applying integration by parts and we need a part that is easy to differentiate. This part is u, sine to the n minus 1x, and we also need a part that is going to be integrated, easy to integrate. That is sine x dx, that will be dv. So we have u is equal to sine to the n minus 1x is derivative du is n minus 1, applying the power rule, times sine to the n minus 2x times derivative of sine x, that's cos x, dx. dv is equal to sine x dx. We anti-differentiate both sides, and we get v is equal to integral sine x is negative cos x. Let's put this in a box. Alright, so what we have is integral sine to the n minus 1x times sine x dx, and we have our integration by parts set up, and we're now going to apply the formula. So I is equal to u times v, that's sine to the n minus 1x times negative cos x minus integral v times du minus cos x times du, that's n minus 1, sine to the n minus 2x times cos x dx. Let's simplify this a little bit. We get I is equal to minus cos x sine to the n minus 1x minus times minus is plus, n minus 1 is a constant, passes through the integral, we get n minus 1 times integral, and cos x times cos x gives us cos squared x times sine to the n minus 2x dx. Now we can apply the trig identity, cos squared x is equal to 1 minus sine squared x. So we have I is equal to minus cos x sine to the n minus 1x plus n minus 1. Let's replace cos squared x by 1 minus sine squared x. 1 minus sine squared x times sine to the n minus 2x dx. Now we're going to distribute this 1 times sine to the n minus 2 and sine squared x times sine to the n minus 2x. So you can see the powers add up to n, and we get sine to the nx dx, which is what we're looking for. So that's the direction that we're going in. I is equal to minus cos x sine to the n minus 1x plus n minus 1. Let's split up the integrals. Integral sine to the n minus 2x dx minus n minus 1, and sine squared x times sine to the power of n minus 2x, the exponents add up to n. So we get integral sine to the nx dx. And this part is what we're looking for. This is I, because I is equal to integral sine to the nx dx. So let's simplify this a little bit more. We're going to pull this part to the left-hand side. We get I plus n minus 1i is equal to minus cos x sine to the n minus 1x minus n minus 1 integral sine to the n minus 2x dx. Now, you can see on the left-hand side, we have I plus n minus 1 times I. And if you open that up, you're just going to get I plus in minus I. So we're going to get in is equal to the right-hand side. And that brings us to the next step. So we're going to divide both sides by n, and we're going to get the reduction formula. I is equal to negative 1 over n times cos x sine to the n minus 1x sine to the n minus 1x plus n minus 1 divided by n times integral sine to the n minus 2x dx. Now, let's not forget what I represented. I is equal to integral sine to the nx dx. And we have proved this reduction formula. That's equal to negative 1 over n times cos x sine to the n minus 1x plus n minus 1 divided by n times integral sine to the n minus 2x dx. We can use this above reduction formula to solve integrals of this type. Integral sine to the 4th x dx. That means, of course, n is equal to 4. Integral sine to the 8x dx. N is equal to 8. Or integral of sine to the 6x dx with n equals 6. So we basically repeatedly apply the reduction formula to solve the integral. So let's apply the reduction formula for integral sine to the nx dx to solve integral sine to the power of 6x dx. So the formula that we have is integral sine to the nx. We derive this formula. This is equal to negative 1 over n times cos x times sine to the n minus 1x plus n minus 1 divided by n times integral sine to the n minus 2x dx. The first thing to do is to plug in n equals 6. So we put n equals 6, and we get integral sine to the 6x dx is equal to, plugging n equals 6 in the above formula, we get negative 1 over 6 cos x sine to the power of 5, because you get 6 minus 1, sine to the power of 5x, plus 6 minus 1 is 5, divided by 6, integral sine, 6 minus 2 is 4, sine to the 4th x dx. So you can see where this is going. Now we're going to apply the reduction formula again for n equals 4. So we're going to plug in n equals 4 into the reduction formula. So we have n equals 4. Putting this in, we get integral sine to the 4th x dx is equal to negative 1 over 4 times cos x sine to the power of 3x, because we get 4 minus 1, sine to the power of 3x, plus 4 minus 1 is going to be 3, divided by 4, integral sine to the n minus 2, n is 4, 4 minus 2 gives us 2, we get sine squared x dx. We're now going to reapply integration by parts formula, the reduction formula, sorry, and we do this for n equals 2. So n equals 2, integral sine squared x dx is equal to negative 1 over n is 2, cos x, sine, 2 minus 1 is 1, so we get sine x, plus 2 minus 1 is 1 over 2, integral sine to the 0x dx. That's sine x to the power of 0, which is just 1. And integral of 1 is x. So what we get is negative 1/2 cos x sine x plus 1/2 integral of sine x to the 0, which is 1, and integral 1 dx, that's just x. And now we have to put everything in the right place and use a lot of bracketing to solve for the integral of sine to the 6x dx. Now let me just make a point here that sine x to the power of 0 is equal to 1. So sine to the 0x is equal to 1. All right, so when we put it all together, what we have is the goal of this question was to solve integral of sine to the 6x dx, and what we get is negative 1 over 6 times cos x sine to the 5x plus 5 over 6 open bracket negative 1/4 cos x times sine cubed x plus 3/4 open bracket negative 1/2 cos x times sine x plus x over 2 close bracket plus c. If we simplify all of this, we get this expression. So basically what we've done is we've proved the reduction formula, integral sine to the power of nx dx, and we applied the above formula for n equals 6. So we plugged in n equals 6, we did repeated application of the reduction formula to integrate sine to the 6x dx. You can tell if you had a higher power, say integral sine to the 20x dx, then you have to reapply the reduction formula many times. All right, thanks. I need to make a slight correction to this video. On the second page, on the last line, this minus should be a plus. All right, thanks.